All right, it's day 2 now. We've got surface area of cylinders and cones. All right, I'm pretty sure you guys know what these look like, but just in case, a cylinder, think of it as like a can, right? Like a soup can or a soda can, whatever it might be, or a bucket is another thing, right? So its bases are made of circles. Most important dimension of a circle is that radius, right? We use that all the time. And then it's got a height. Okay. Now, when we're trying to figure out the surface area of this, we're going to be taking our two circles, and then we're going to be taking whatever this is that wraps around it. I'm gonna let you guys think about that for a sec before we get going. All right. Then we have a cone. So a cone it's got a circle base, and it comes to a point. It's kind of like a circle base pyramid in a way, but not really. All right. Once again, our radius of the circle plays an important part. And then also our slant height. Much like in a pyramid, it has a slant height. It also has a height. But when it comes to surface area, the dimension that is on the surface, the slant height, is the more important dimension for us. Okay, awesome. Well, let's get into it. All right, so for this problem here, it just asks for the total surface area of the cone. But as we know, the total surface area is broken up by the lateral area and the base area. Well, here the base is just a circle, so it's pi r squared, right? Um, but the lateral area is a little bit different with the cone. It actually has its own special formula. And it is pi times my radius times my slant height. And my slant height is this right here. And we use a cursive L to notate that. All right. So make sure that you guys write down both of these right here. I mean, I guess the circle you should already know, but that pi RL is new. If you were to take a look online, you might actually see that L is replaced in the formula with square root of r squared plus h squared. Well, what are they referring to there? Well, they actually just did the Pythagorean theorem with this triangle right here, which is something we're actually going to have to do, right? But if you notice, it's a 15 and a 20. That's actually a 3, 4, 5 triangle that's been multiplied by 5. So that means that my L, in this case, my slant height is going to be 25 centimeters, 15, 20, 25. Okay. I think we have all of our dimensions that we need. So let's go for it. I'm going to do my lateral area in blue. So that'll be pi times my radius of the circle base, which is 15, times my slant height, which is 25. And if I were to multiply 15 and 25, I end up getting 375 pi. Okay. And I'm going to leave it like that. Exact. And if I were asked for nearest tenth or nearest hundredth, I would just multiply them together, 375 times pi. In the end, we'll give both. Now, for my base, I'll go ahead and do that in, how about, uh, ooh, let's go with this different color. Here we go. All right. So for my base is just the area of the circle, pi times 15 squared, or 225 pi centimeters squared. All right. So I've got my two parts. I've got this one here. I've got this one here. What do I do with those two? Add them together. I'm going to end up getting my total surface area of 600 pi centimeters squared, or I could multiply this out. 600 pi is going to be approximately 1,884.955. So we'll call it 96 centimeters squared if we're doing nearest hundredths. Lovely. That's a wonderful problem. All right. So if we didn't have nice numbers, we could do Pythagorean theorem to get our slant height. You'll see it on the Google machine written in that way. They'll replace this cursive L with this mess right here. But I'll tell you what, this looks a lot cleaner if we remember what the L is. That is our slant height. All right, we got ourselves a right cylinder here. Okay, we got to find the surface area of that cylinder. The measure of angle A is 30 and AD is 12. Okay, so if this is 30, that's some old-timey PowerPoint, when we didn't really have math type. Old school. And then AD is 12 centimeters. Well, this, let's see here. To figure out stuff with the cylinder, I need my radius of the circle, right? That's really what it all stems around. And we're going to talk about that lateral area in just a sec, but the three piece or the couple things I need are my lateral area, my bases, which are circles. So that one's usually pretty easy, and then total surface area, which would be all that together, right? So let's see here. I think the first thing we need to do is figure out our radius. Okay, we're going to talk about lateral area in just a sec, but circles are something that we're familiar with. Let's get that radius. Well, if you look here, I have a triangle within that, right? That's a triangle there. I'm going to get rid of that so it doesn't get too congested. But we have a right triangle, and this up here is 60. Well, if this hypotenuse of this triangle is within the cylinder is 12, then my height of the cylinder is 6, right? We reviewed our 30, 60, 90 the other day. 1, root 3, and 2. Often we have an x with those. Okay. So that would mean that the diameter is going to be 6 root 3, which means my radius is half that, 3 root 3. Awesome. So my bases, we'll start with that. Let's see here. My bases, we'll start with one base and then we'll convert it to two of them, is going to be pi times my radius, 3 root 3 squared. Now, it's important to remember to put that in parentheses because not only is the root 3 getting squared, but the 3 gets squared as well. So I have pi times 9 times 3, or in other words, 27 pi. And if I'm working with my bases, double that, it's 54, not 55, 54 pi centimeters squared. I like it. Lateral area. All right. This is something that I'd love to do in person. Is what I usually do is I take a piece of paper and I wrap it around like something that's circle. Okay. But I want you to think about a soup can label. You ever pull those off, right? They come off, they're just glued on there. You can take them off. When you unravel a soup can label, what shape is it? That shape from being around here, right? That soup can label, this thing right here. When you unravel it, it's actually a rectangle. If you don't believe me, see if you got a soup can somewhere or look up a video of somebody unwrapping a soup can because I mean you gotta see it to believe it, I guess. All right. Well, this right here we know is 6, right? It corresponds to this. But what is this measurement up here? Well, this actually wraps around the top. In other words, it is my circumference. And we know that my circumference is 2 pi r or pi times diameter, right? But we got to find our circumference. I've already got my radius. Let's pop that bad boy in. So now I'm going to have 2 pi times 3 root 3 or 6 pi root 3. So that would be the dimension going across right here. And this is just a rectangle. So my area of this rectangle is base times height, or there we go, my two dimensions multiplied together, which will be 36 pi root 3 centimeters squared. Now, because of this wonderful root 3 that we have going on here, I cannot combine those two as like terms. So my final answer is just going to be 36 pi root 3 plus 54 pi centimeters squared. But I could plug this into the calculator. 36 pi square root 3 plus 54 pi. And that gives me a grand total of 365.536. So either 0.54 or zero point 0.5 centimeters squared. And boom, there are my two answers for the total surface area. All right. Big key point here, guys, is the lateral area. I'll do this in a different color. Lateral area of the cylinder is a rectangle with one dimension being, that is a little sloppy, a little too close together there. My apologies. Being the circumference of the circle base. All right. Sorry, I'm running out of room. But I would jot this down. Okay. Right. The other dimension's the height of the cylinder. But the one that's like weird to think about is the circumference. All right. Awesome. Let's do another one. All right, we got ourselves a nice little last problem here. A combo mambo, as I like to call them. Just kidding. It's called a composite figure. All right. So we got a cone and a cylinder stacked together, and we want to find the total surface area. It's very important to be organized in this. All right. So I've got one of my key dimensions here, which is my radius, right? That's super helpful. So let's just work from left to right. Let's work from the cone on to the right. So my cone, lateral area of the cone, that's what I'm looking at there, is going to be pi times my radius of 4 times my slant height, which is already given. I don't even need my actual height of the cone to find the surface area. I'm not going to bother. I could find it, but I'm not going to. So this gives me 32 pi. All right. Lateral area of the cone is done. Now, this base that is within here, this is not on the surface. This circle is inside the solid. It is not part of the surface of it, so we do not worry about it in the surface area. So our next move is going to be lateral area of the cylinder. So my lateral area of the cylinder is going to be, remember that rectangle that wraps around it. That rectangle that wraps around it. So to figure that out, I'm going to need not only the height of that cylinder, but also the circumference of the circle base. Because when I unroll it, I get this rectangle that will be 3 meters, and then 2 times pi times 4, which is my radius, or 8 pi meters. So those are my two dimensions of the rectangle. Multiply them together, I get 24 pi meters. All right. Pop some units on there and here. Last but not least, I do need a circle, but it's that one out there because that one's on the bottom. It is on the surface. It's not within the figure. So let's see here. Circle base is going to be pi times my radius, which is 4 squared, or 16 pi meters squared. Oh my goodness. I forgot my squared on these units. I'm going to leave that in there, as mistakes do happen, but you do have to be responsible for them and catch it. All right. So my total surface area, if I add all these up, 16 plus 24 is 40, plus 32, 72 pi. All right. Meters squared. Let's do a decimal approximation, shall we? So once I got my 24, my 16, and my 32 pi, right? If I just multiply that all out, so 72 times pi, oops, 72 times pi, got to plug it into my calculator correctly. Ooh, man, that's another voice crack. I don't know what's going on with me. I need to drink some more water. All right, 226.19 meters squared. On a normal paper pencil test, we're going to usually ask for exact units, which would be the 72 pi meters squared. But if I ask for a decimal approximation, you would just plug it in and we would get the 0.19 or zero point 0.2 if it was nearest 10th. All right. Nice work, you guys. So, a couple of those important formulas. Make sure you have those down. If you need to skip back in the video, do that. For that lateral area of the cone, that was really the main one. That's a new thing. Everything else is circles and rectangles. So, bibbity bop, just don't stop. America, freedom, rock and roll, Costco, and hashtag Yo Row, and at River Dog Jenny, Instagram. Peace.